So now I'm going to talk about what is open source operating system. I mean, you might be hearing open source a lot of time. Okay, so open source. So open source, it in terms of open source means operating system whose source code is made available to the public for allowing users to add and develop or inspect and modify and contribute to the code. Let's say I have software. Example, I have a software. I'm releasing that for free downloadable with the source code. Means I can provide my whole code for publicly, and they can download that code and they can modify. I mean, they can inspect. Like when I say inspect, okay, Venkat is created the software with the A B C. Now I want to change a program to some XYZ by adding some XYZ features. So like that, the open source model system is very useful. So whoever having a deep knowledge on the C programming or the low level languages, they can download this source code and they can inspect and they can modify and they can contribute to the code. So when I say contribute to the code is nothing but um, they can add some features to the existing source code, and then they will release it for for others to use that modified source code. So open source operating systems are typically distributed with a license that grants users to right to use, modify and distribute the software freely. Means they might have some license and terminology, but it doesn't mean that they cannot modify or they cannot inspect or they cannot contribute. That means they can do anything and they can freely usable these things. Okay, so we have a different as I mentioned, like we have a different distributors out there. So especially like Red Hat, Ubuntu, Fedora, or Debian, all we have in this model. So as I said, mentioned, it is to we can use it for inspect, modify, and contribute the code. So as I said before, Linux is a one of the freely available, so that anyone can add their features. So what are all the main key architectures? Key characteristics of open source software, right? So the first one is mainly when we say about the open source is that's access to source code. So access to source code is nothing but open source software provide user with the access to the source code, which is the human readable form of the program. So this allow user to understand how the software works, make modifications and contribute for improvement. Means as I mentioned, I am the one or I can provide my code for the end users. They can understand how it is written and where they can make modification or how they can contribute. Like that, they can do it because of this access to the source code and all. And the second one is something distribution right. As I said, distribution free from use this distributed software means you don't need to you don't have any issues with using the my source code because it is free, because I'm giving this software for free and you can modify. And the licensing, as I said, the licensing part is something typically released under the licensing, but when I say licensing here, it's called a GNU, generally public license. Okay, so common source, open source licensing, all these are something of fall under the GNU, general public licensing way. So licensing is something released under the license, so you don't need to worry about the uh, who can modify it or not. And there are some other when I say open source software, like we have a Linux, Apache HTTP server, and Mozilla Firefox, and GNU compiler, like that. We have a different kind of open source softwares that are out there right now. So we have another key characteristics of is community collaboration. This is uh, very important. Community collaboration means like mm, let's say there are a couple of people who contributing their modifications or code updates to the users, so they can collaborate each other, they can discuss or they can push the changes uh, together with the team. So that's called a community collaboration. Also, when I say community collaboration, who are like developers and users who collaborate their development process, testing process, and improvement of the software. So communication usually happen through forms, like mailings or version control system. Right? As I said, I created one feature. I'm communicating that through a version control system, maybe a Git. Using a Git, I can do it, or maybe a mailing. Maybe I can share my code to the some X party, or maybe a forum. So from the forums, we can talk about the what does that particular feature is doing, how it is beneficial for the end user, like that. We can communicate towards the uh, software development update into that particular whatever software, right? So this is how the open system source open system works behind the scene. So what are you going to take from this? So you just need to understand what is open system. You need to understand it's a free, who can download, you can inspect, or I can modify and contribute the code for further enhancements. That's it. So now talk about distribution, right? So distribution is something. Sorry. So distribution is something. Sometimes we call it as a distro. So distro is a complete operating system based on the Linux kernel, along with the various other software packages that provide a user-friendly environment, right? So when I say user-friendly environment means maybe that operating system is having a different tools to give a best visibility to the end users, and some packages which use more um, more interesting to every time go and download that particular software, like that, right? So distro, as I mentioned, distro sometimes it is called as a distro, sometimes we can call it as a distribution. So each distribution is built with a specific set of goals. Okay, it's a set of goals and designs principle and target audience in mind. Means, as I said, uh, let's say example, in reality, like Amazon is having, Hotstar is having, Netflix is having. So all these are, let's assume they are the distributions or distro. And if you opt for Netflix, you will get a different way of experience. Means you will get some a series, couple of high quality series, and you will get different sci-fi genre movies, whatever. When you opt for Amazon Prime, what you will get the Amazon Prime subscription followed by the Amazon Video. You can also when you order, you will get that whatever grocery or whatever items in 1 day delivery, or you will get some additional benefits like that. So this distribution is something, software packages that provide a user-friendly environment. So each distribution is having its own features or principal design goals. So we cannot compare, uh, like I said, you cannot compare Netflix with Amazon or Amazon with Hotstar, right? So it is easy to use and install, and it comes with a comprehensive set of utilities and applications, including like example, X window graphical system, genome system, KDE system, GUI environment, and there is a Star Office suite, which is an open source MS Office clone for Linux. So all this something uh, somebody has to provide, right? Those are comes under the distribution. So there are different development distributions out there. I mean, when you talk about outside the market, we have a different uh, software providers. Like Red Hat is the top one, who is a leading company or who is the leading OS who provides the operating system for enterprises workloads. So most of the, I mean, with my experience, 90% of people relying or using the Red Hat. Okay, then after maybe Oracle Linux, CentOS, and Ubuntu and Fedora. But Red Hat is the top place who gains um, customer satisfactions and whatnot. I'm going to give you a high level overview on the Red Hat. Why would you choose the Red Hat, not any other OSs for enterprises workloads? Okay, and Ubuntu is something known for user friendly interface. So most likely Ubuntu is used for your desktop versions, not in the server. Yes, Ubuntu is offering server editions like Ubuntu Pro, or I mean you can use it for server editions. But yeah, if your workload is not that critical, or customer is not worried about any licensing software and all, then yes, we can go with the Ubuntu. I'll give you that differences as well between the Ubuntu and Ubuntu Pro. And we have a Fedora. Fedora is something sponsored by the Red Hat. Means it is a sub branch or maybe a sub branch or whatever clone of the Red Hat. So that is the Fedora. And Debian, we have a Debian OS and the Arch Linux OS. We have a few more like OpenSUSE. There are many out there, but when you go into in the real use a real world case, most likely you will be seeing first as Red Hat, and the second maybe a Ubuntu, then maybe a Oracle Linux. Let's say if you are working in Oracle and you are supporting all the Oracle customers, then most likely they suggest for OEL. OEL is nothing but enterprises and Oracle Enterprises Linux. And this Fedora is something, as I said, it is a sub branch or sponsored by the Red Hat. So I don't see it in real world case. So I have seen only these first four OSs in real time. So when I talk about real time, the same OS can be useful on your on-premises or in your cloud supporters. Like maybe you can use same OSs on the Amazon as well, or maybe uh, in your Azure, or maybe in your Oracle Cloud, or maybe in your IBM Cloud, like that, or in your GCP as well. So when I say previously a distribution, right? They always do a lot of pre-configured or pre-packaged modules or applications together like a bundle, and they will give it to the end users. So that's how the distributions works behind the scenes. So Red Hat is the topmost place who is having, I mean, who is distributing the uh, broad range of operating systems, releases for the enterprises workload. So then because of Red Hat nature is that it supports a different hardware platforms, like it supports on Intel, it supports on Alpha, it supports on Spark. So these are all like processors family or the hardware family where you can install. It doesn't mean that you cannot install a CentOS on Intel. Yes, you can install, but it's not supporting on Spark OEL. It supports on Intel, or even though it supports on Intel, but it's not in Spark. Spark is something. Spark means it's a special processor, something designed by the Sun Microsystem. Uh, so it supports only a kind of operating system that supports that particular processor, like Solaris 11. Sun Microsystems OS Solaris 10 or Solaris 11, or something supported on the Spark hardware platform. So when we talk about distribution, right? So the distribution further is organized into two sections based on their package management. So when I say package management, it's nothing but how the packages are going to be installed on the operating system. Let's say if you are dealing with your Windows machine, you will be getting a software with a .exe format, or if something package sometimes start with a .msi, so Microsoft installer file like that. So based on that installation type, further it is divided into two categories, right? So one is something RPM based, so this is very popular, and the second one is Debian based. So when I say RPM, there are a couple of operating systems those fall under the RPM based, and Debian based means some of them are like Ubuntu, those are based on the Debian basis. So what is the main differences between the uh, RPM based and Debian based? So that's I'm going to talk about in the coming slide. So before that, before I moving to the next slide, so what are you going to take away from this particular slide? So the thing is, you need to understand what is distribution. So in a short, distribution is having packages. I mean they're giving a software with a um, all packages together to the end users friendly environment use case. So on top, Red is the uh, top place occupied. So now let's talk about RPM based distribution, right? As I said, so based on the installation of the packages. So when I say RPM means it's a Red Hat package manager. So Red Hat Enterprises Linux is designed for stability and long-term support, making it suitable for a mission critical environment. As I said, it's mostly usable for mission critical environment, right? So when I say mission critical environments, maybe your HPC workloads, or maybe your machine learning related workloads, or whatever you are running more than what you are expecting, then you must need to go with the um, Red Hat itself. So Red Hat follows a open source model, but RHL, I mean, we call it as in a simple, we call it as a RHL, right? So RHL itself is a commercially supported product. However, the source code of RHL is made available, and the community supported also is available, like CentOS, right? So CentOS aim is to provide a free and open source alternative with the binary compatibility with the RHL. So RHL and the similar compatibility we have, which is together into a another option called CentOS. So when you say RHL or Red Hat, it is a commercially supported product, okay? But when I say CentOS, that is a community supported. I mean, as you know that community means there are a couple of people from different places or different organization. They might update, or they might support their views or updates as long as it's required. So that is called a community support, right? That is something driven by the outside the users or vendors or people. So as I said, RPM is a package management system used by the Linux distribution. So it's commonly associated with the Red Hat and its sub operating systems. Like, let's say we have a commercial and we have a community supported, as I said before. So when I talk about commercial, we have a Red Hat Linux is the first place. That's the commercial based operating system, and the second one is SUSE. It's sometimes I mean we call it as a open SUSE. So the open SUSE is one of the commercial, and they also have a community supported. So when I say commercial, you always think about they are I mean they are not designed for general use case. They are always used for high-end workloads or mission critical workloads. It doesn't mean that you cannot use as a normal workload use case, but it is a licensing. You need to purchase the subscription then you need to use it because it is a commercial by the particular vendor. Let's say if you're having, I mean, if you're taking the Red Hat, then you need to purchase it from the Red Hat company. Okay. If same with the SUSE Linux. If it is SUSE, you need to have the SUSE license terminology. So when it comes to the community, right? So the community supported CentOS is one of the example for community based one, right? And then we have a Fedora, and then we have OpenSUSE, and then we have a Oracle Linux. So this Oracle Linux is uh, something that managing by the Oracle. So um, when I say managing the Oracle, um, they have their own software, I mean modifications and all. Means they took the base image and on there they install, or they packaging, or they customizing according to the Oracle requirements and all. So Oracle Linux is one of the one more RPM based package distribution OS. So even if you use RPM based like Oracle or Fedora or OpenSUSE, CentOS or Red Hat, you will be installing a packages with the extension of RPM. I mean the package start, I mean end with the .rpm extension. That means that's RPM based operating system. So when I say, as I said, package format, right? It's always end with the .rpm, and you need to use the commands called RPM. So RPM is the command to install your package. Let's say you want to install maybe something like a glib or OpenSSL library, whatever that you can use to install it. Okay, so no worries. I'm going to create two systems when we talk about um, a Linux OS in detail with a live example. Then I will try to create two ways. One with the RPM based distribution. Maybe I can take CentOS, Oracle, or Red Hat, and one with the Debian. So you will get idea in detail when I am doing that. The next one is Debian based, right? So as I said, Debian based is something managed by the Debian package management system. So most of the time, the packages end with the .deb extension. So this Debian package is something OSS falls under the uh, uh, two categories, as I said before. Most likely, uh, either it's a non-commercial, means you don't need to purchase, it is a freeware like Debian, and some of the commercial versions. As I said, Ubuntu is having two versions. One is a desktop version, and the second one is what I call like server edition also, and pro version also. I have one more slide where I can talk about that. So desktop version, um, most likely it's like a, normal use case purpose we need to use, but if it is servers, yes, we can use it for server edition as well. There are other couple of operating system we have in the market like Linux Mint, Kali Linux and all, but I never seen these two ways like Linux Mint and Kali uh, operating systems in the market. I always worked on Red Hat, CentOS, OEL, um, and Ubuntu, right? These are the four primary OSs that I supported till today. So as I mentioned, the software packages are typically start with the dev format. I mean, when you deal with your Ubuntu operating system, when you try to install with the apt command, I mean there is a commands like apt or apt-get or apt-get install. So using that you can install your packages, or you can update, or you can install, or you can remove the packages. So that's it about the Debian based distributions, right? So now when I say a commercial Linux distribution on AWS, right? So AWS is supporting a different operating system similar to on-premise. The one we discussed previously, previous slides like Red Hat, CentOS, Oracle, and Fedora and all this can be also used on premises as well as on your Amazon. Not only Amazon, any cloud vendor can be a Amazon, can be a Azure, or can be Oracle, or can be a IBM, right? So all these are comes under the commercial. I mean, a commercial version when you go on the AWS side. And community, yes, it is a CentOS, even though open source and all this. So where to use in general? I mean, so far we talked about distributions and the RPM based or Debian based. But end of the day, or the goal of the operating system is you need to use somewhere, right? So operating system should be used on either on the your on-premises or maybe on your cloud workload. So when I say on-premises applications like SAP, Microsoft SQL, or Oracle database, and custom applications in the cloud means not only for SAP, maybe you can use it for Oracle SQL or WebLogic. There are different softwares out there. So based on the software, you need to decide which operating system is suitable for you. So in real time, right, when you are into a architect role, I mean, you are the person who is designing or who is architecting the some ex customer design, and you as a person, you need to think what operating system is suitable for the customer. You need to analyze everything what customer is currently running, or if it is a customer is new to the environment, or they want to start their journey into the on-premises environment or cloud journey, and they want to launch some similar to a Facebook or similar to your Zomato app, then you need to consider which operating system is suitable for them. So based on their inputs, you need to decide. So most of the time, if customers are investing heavily based on their workloads, then most architects are always suggesting on the Red Hat. But if customer is not worried about I mean, their business is that much not critical, and they might go with a lower operating systems, like maybe something like CentOS or OpenSUSE, or maybe an Ubuntu. But as far I know, as far I've seen in my 10 years experience, 90% are Red Hat Linux, maybe a 10% on different OS categories like Ubuntu, like that. So that's all about commercial versions, right? So now this is a very important that I'm going to talk now. So architecture of Linux, right? So architecture is one of the important topic here. You need to understand. Again, from here also, you don't need to worry like, hey, what I need to take away from this. So in simple, you need to understand how things are working behind the scene. Okay, as a fresher, or as you want to become software engineer, you need to understand the architecture of OS. So this OS is similar for everything. I mean, any other Unix or Linux flavors. So this is a high level design of it, right? So what is architecture? So architecture of Linux system is based on the module and multitask design. We talked about multitask, right? So it's based on the multitasking design, and it's follow an monolithic kernel architecture, where the kernel provides a large set of functionalities as a single tightly integrated unit. Okay, so there are uh, different steps that involve behind the scenes. So first it start with the user. So user means who? Like, as an end user, you are the user, and you need to deal with your system, and you want to write some program, or you want to store some program, or you want to design something and you want to store in your PC or server. Then you and user, you need to initiate your first connection in the sense, you might be opening your putty, don't forget, don't confuse about what is this putty. So it's nothing but you are connecting to your server with the some tool. So the tool here is a putty. So in the putty you need to insert your server IP or name. Then you need to, it will ask for the username and password. Then you will be entering to the particular server. So you as a user, before you start writing or start storing something, you need to first authenticate to the system. That's fall under the user. The second one is applications, right? So this is where the actual uh, uh, programs or whatever, it will be happening behind the scenes. So when I say here um, applications, it can be a system libraries, or it can be a utilities, system utilities. So when I say a system libraries, means it is a collection of pre-compiled functions and procedures that provide essential functionality to the applications, right? Example, glibc, it's a genome library, and some of the programming languages, right? What do you need this? Because to abstract the low level hardware details and enabling application developers to write portable code, right? This is important aspect of applications. The next one is system utilities, right? So when I say system utilities, right, it performs the various tasks such as like managing the files, user accounts, system configurations. Uh, some of the utilities, like when you talk especially on the Linux or Unix, there are different utilities, like we have a ls command, we have a cp command, we have a move command, grep command, find command. There are a lot many more commands inside the utilities. So where do we use, how do we use, it's all something controlled by the applications programs, right? So I'm going to talk about what is these utilities like cp, move, and all these on day 3 of our series, where I can talk in detail how you deal with the system utilities. The next is comes onto the picture is which is important, that's a cell. So cell is a command line interface that allow users to interact with the operating system by typing commands. So when I say typing commands, you as a user, you write, initially you connected to the server, then you're not sitting idly, right? You need to write, or you need to execute some commands. So those commands, something it is allow users to interact with the operating system. So those commands are automatically forward to the your operating system behind the scene. So the cell interrupts user commands and execute them, and provide a powerful and flexible interface for the system administrator and application execution. So means you executed command, then that command will send to your operating system. Okay, then operating system will analyze what is that, and what is that input and what is the output. That is something it given to the end users. Okay, let's say example in a short, when you compare with your windows, let's say you connected to your windows pc, and you try to open a microsoft excel file. So here opening is excel file is a utility like a application, and open, when you double click or whatever you do, that's something shell command. You are asking to, hey, open this file. That comes under the cell, utilities cells. So that cell is going to be interact with your operating system. Okay, this guy is asking to open this file, then I need to open, like that. The flow will be happen behind the scene, right? That's all about cell. So when I say, if somebody asking what is cell, cell is a command line interface that allow users to interact with the operating system by typing commands. So you as a user, you need to run, then only you will interact with your operating system. So that will convey the message to your operating system. Then fall into the linux kernel. So the linux kernel is the core operating system, right? It manages, as I said before, it manages hardware resources and provide essential services such as a process management, memory management, device management, file system management, and system calls. So the kernel is responsible for integrating with the hardware and facilitate communications between the hardware and user level application. So as I said before, if you want to store something, you need some mediator, right? You cannot directly, hey, I can't write, I mean, I can write directly some file into the hard disk. No, it is not possible. Some interface is required between your hardware and the user. So in between, the kernel will take care of about that particular role. Means it is integrating, it is integrating your hardware between the user and inside some application cell and all. It's integrated. That's all about the cell. That's all about the kernel. So in short words, kernel is the heart of the operating system. It manages hardware resources and provide the essential services such as process management, resource management. So kernel is the only the way the process controller, resources controller is happening behind the scene. And then we have a few more like hardware. So I talked about hardware is nothing but how your operating system is going to interact with your operating system. Means your hardware, like hard disk, CPU, like that. So everything is something fall under the hardware. So this is how when user is asking for something, this flow is happening within a seconds, then the user will get output. So yeah, that's it about the architecture of Linux. That's it for now, right? So you can follow me on the Facebook, or you can follow me on uh, my Instagram channel, or you can follow me on Telegram. So where you will get any PPT or any content that I'm going to create, I will share on that my Telegram channel. So I hope you like this video. So kindly like, share, comment, and subscribe to my channel.